So this is the problem. If two diagonals of a quadrilateral bisect each other, then the quadrilateral will be a parallelogram. This is the theorem. If two diagonals, these and this, these are two diagonals, AC and BD, these are two diagonals. So AC and BD are two diagonals of this quadrilateral, and, and this is a theorem. It says that if two diagonals of a quadrilateral, this is the quadrilateral, if these two diagonals bisect each other, this is the point where it bisects AC and BD. This is the point where they bisect each other. Then bisect means divide equally. So that means AO is equal to OC and BO equal to OD. If this happens, if the diagonals, two diagonals of this quadrilateral bisect each other, then this quadrilateral is a parallelogram. This is the theorem. This is not the problem. Okay. So this theorem is given. Now we have to state and prove the converse of this theorem. So what is the converse of this theorem? This theorem states that in a quadrilateral, if the diagonals bisect each other, means AO equal to OC and BO equal to OD, then it is a parallelogram. So the converse of this theorem is that the diagonals of a parallelogram bisect each other. That is the converse of this theorem. The converse is that the diagonals of a parallelogram bisect each other, which means if this is a parallelogram, then its diagonals will bisect each other. That means AO will be equal to OC and BO will be equal to OD. BO will be equal to OD. To prove this, we have to use a few properties of parallelogram, and we also have to use congruency of triangles. Let me first state the properties of parallelogram that we will need. That opposite sides of a parallelogram are parallel and equal. This is one property. If ABCD is a parallelogram, then its opposite sides AB is parallel to CD and AD is parallel to BC. That is what it says. And also they are equal, means AB is equal to DC and AD is equal to BC. That is what this property says. We will use this property in solving this problem. And then again we will use ASA congruency of triangles. Now what is this ASA congruency of triangles? A means angle, S means side, and A again means angle. So this congruency means angle, side, angle, congruency. Let me elaborate on this ASA congruency little bit more. This ASA congruency, it means that if in two triangles, suppose this is one triangle, in two triangles ABC and PQR, if angle A and angle B, two angles, this one and this one, and PQR, this one and this one, if two angle and the angle between the two sides, the included side A and B, this is the included side, and PQ, this is the included side. So if angle A is equal to angle P, this is equal to this one, and angle B is equal to angle Q, and the included side AB is equal to PQ, this included side, then the triangles ABC, PQR, triangle ABC is congruent with this triangle PQR. That is what this means. ASA congruency of triangles. So we will use this property of parallelogram and this congruency of triangles to prove that diagonals of a parallelogram bisect each other. That means they divide equally. When they bisect, they divide each other equally. That is, AO is equal to OC, AO is equal to OC, and BO is equal to OD. ABCD, this is a parallelogram. It is already given. Since this is a parallelogram, then we have AB is equal to CD. So that follows AB is equal to CD or DC. These two sides, this side and this side, they are equal and parallel. AB is parallel to BC. Opposite sides of a parallelogram, they are equal and they are also parallel. Now, angle OAB, this angle, is equal to angle OCD. Why? Why OAB is equal to OCD? What is the reason? Angle OAB is equal to OCD because, let me draw it like this. This is AB, this is CD, two opposite sides of a parallelogram, and this is the transversal AOC or AC. This is the transversal. Now, since these two sides AB and CD or DC are parallel and this is the transversal, it implies that this angle and this angle will be equal. By the way, I forgot to add another property here, that alternate interior angles of a transversal are equal in case of a parallelogram. That means when there is a transversal in a parallelogram, then alternate interior angles, this is the transversal and these are alternate interior angles. Now, according to this property, then the alternate interior angles, this one and this one, they will be equal. So this is another property we have to remember. So according to this property, since AC is the transversal of these two lines, two parallel lines AB and CD, This is the same line. S is the same line AOC. This is the midpoint. So OAB is equal to OCD. OAB is equal to OCD, which means this angle is equal to this angle. Okay. Again, OBA equal to ODC. Why? This angle is equal to this angle. Why? Again, let me draw the semi structure. AB and CD are opposite sides of a parallelogram, and BD, this is a transversal. AB and CD are opposite sides of a parallelogram which are parallel and equal, and BD is the transversal. Here is the midpoint O. So BOD, this is the transversal. And if this is the transversal, then the alternate interior angles are equal according to this property. So OBA, angle OBA is equal to angle ODC. So reason is that alternate interior angles of a transversal. Here the reasoning is same. So in these two triangles, AOB and OCD, hence this triangle is congruent to COD triangle. Angle AOB is equal to angle, triangle AOB is congruent to triangle COD. By which formula or property? It is because of the ASA congruency of triangles. Angle, side angle. This is the reason. Two angles and the side equal. Two angles and the included side equal. This one is equal to this one is equal to this one, and this one is equal to this one. So we have the corresponding angles and the side in between, they are equal, so these two triangles are congruent. Now, if they are congruent, it follows that AO equal to OC. AO equal to OC because they are corresponding sides of congruent triangles. AOB and COD are congruent triangles, and AO is the corresponding side to OC, and BO is corresponding to OD, hence BO is also equal to OD. So we have AO equal to OC and BO equal to OD, which means the diagonals bisect each other or divide them equally. So by using this formula and congruency of triangles, we can prove that in a parallelogram the diagonals will always bisect each other.